In this video, we're going to take a quick look at the ideal gas law and another concept that we call molar volume. If we look at our temperature and pressure as STP, we'll see that we've got a temperature of 273 Kelvin and a pressure of 1 atmosphere. If we plug these values into the ideal gas law, leaving volume and moles as variables and including the appropriate constant, if we rearrange the equation and isolate our volume and moles, we'll get a ratio of our volume to moles of 22.4 liters per mole. Now this is an important concept because what we've done just now is if we have standard temperature and pressure, we've eliminated the need for using the ideal gas law. We now have a conversion for liters to moles directly. So if 1 mole would have a volume of 22.4 liters at STP, our conversion would be 22.4 liters equals 1 mole. And this is true for any gas, as long as the temperature is at standard and the pressure is standard. So anytime you have a question that has temperature and pressure as being STP, or standard temperature and pressure, you can use this conversion rather than plugging into the ideal gas law. Let's see this in action. So if we have hydrogen and oxygen react forming water, if 5.03 liters of that oxygen at STP react, what mass of water will form? So first thing we do is write out and balance our chemical equation. Our first conversion would be to convert that liters to moles. As with any stoichiometry problem, we have to do a mole-to-mole conversion, and to be able to do that, we must have the unit of mole. We're using this conversion at standard temperature and pressure of 22.4 liters equaling 1 mole to accomplish that. From here out, we can continue on with our stoichiometry. We set up our ratio of 1 mole of oxygen, because in the balanced equation we have 1 mole, to 2 moles of oxygen. Now that we're in moles of oxygen, we can continue on to get to our grams of oxygen and eventually get our 8.09 grams of water. What we have essentially done is we have replaced our ideal gas law with the conversion of 22.4 liters as 1 mole. The only way we could have done that is if this reaction, and it was, as at STP. If we had temperatures and pressures that were different than STP, we would not be able to use that step of 1 mole is equal to 22.4 liters. We would have to go through and do the ideal gas law.